Okay. Mm. Right. Good afternoon, everyone. So, last 2 weeks we looked at, in fact, until last week we were looking at testing, right? So we were looking at testing standards, testing levels, testing techniques, all that stuff. So from today we'll be looking at quality management or quality standards, because testing is one side where we are looking at a completed product, right? Whereas quality control is about managing the process where we start from the day one, building to completion, and then also handing over to the customer. So, quality standard, there are few different quality standards we need to understand the differences of. Because when you are joining a software industry, many companies are either going through ISO. If it's a software company, most of the time it's a CMM standard, right? CMMi now. Sometimes they'll have a mix of that. They also have something called Six Sigma. So either case, there will be some sort of quality standard going on in organizations. Most of the time it is CMMi, but that is specifically designed for software companies. So knowing about these standards will be very helpful when you're joining the IT industry. Right. So let's look at some definitions first. So the standards, when you say whatever the standards, right? Not ISO, any standard. When you introduce any standard, that will reduce the activity of reinventing the same. We call it reinventing the wheel. That means when you have a standard, it will allow you to spend time on other things rather than, reinventing or redoing, recoding, refixing stuff, right? So as it says, standards reduce the activity of reinventing the same or similar processes for development and QA. Meaning, if you have a sort of a standard, that will reduce the requirement of redoing the processes. Yeah, we'll see what it means. Not just standards, there are also models, there are guidelines, there are so many things that companies would like to incorporate, because by incorporating these standards and all these things, what we are actually doing here is we are reducing the time required for retooling, wasting our time. So point number one, vital attributes of standards is consistency, sorry. So when you have a standard, you have consistency. That is the same thing coming out. Same product, same process, same quality is coming out because there is a standard. But at the same time, the standard should be flexible also. Now, what does that mean? Now, let's say if we are doing the same standard that was invented 50 years ago, that's also bad, right? So technology is changing. And a good example is actually ISO. ISO, we will look at the differences. When ISO came along, everyone wanted to jump at it and say, right, okay, here's the way of going forward. But after a while, they realize ISO is good, but it doesn't fix the problems we have with software companies. So then Carnegie Mellon University came up with the CMMi model. So that's a change. And then Motorola has their own way of doing checking the standard called the Six Sigma standard. So whatever the standard, it should be flexible also. So when something new happens, we should be able to change our standard as well. And the third point is very, very important. Standard should be usable and understandable. Now, what does that mean? Now, if your standard doesn't allow you to do your work faster or properly, then that's a bad standard, isn't it? We want to do our work fast and, better. And the standard should be helping you to do that. And if it doesn't, if it slows you down, then we have a serious problem with our standard. And the other thing is understandable. So it should be very easy to understand. If the standard is very complex and you need a dictionary along the standard, then, well, people will not adapt the entire standard. They will only adapt what they can understand. Right? And also, standard can streamline transitions when developers leave projects. What does that mean? Standards can streamline. Now, you see, any company, people are not there forever, right? People come, people go. And these people are also, they have different qualification, different experiences, and they have different ways of working. But the company cannot change according to the people that is coming in, because people will go also. So if the company has a standard, then whoever is coming in will work according to the company standard, not the other way around. Company will not work according to the people standard, right? So in this case, if the company has a standard, people can come, people can go. The standard will be there. And your projects will not get hampered and your company will not have any trouble because the company has a standard. Okay. So the last point is, one of the key components when it comes to quality assurance is having some standard, right? So some standard is what you're saying, but there are a very matured way of doing things. So we'll get to that and see what are the best way, what are the other people doing, and what are the best way of doing things, right? So according to Cram and Graziano, they spoke about what is a standard, right? So different explanations are there as to what is a standard. A standard provides consistency across projects, meaning you will not have one standard for one project and another standard for another project. No, you will have only one standard for all the projects in the organization. And then it eliminates conjecturing. What does that mean? Guesswork. So guesswork is where you don't know exactly what is going on, and so you're guessing things. So where is the documentation? Okay, in the first project, there is a folder called documentation. So that is where we had the documentation. In the other project, we had documentation outside that and then in somebody else's computer. So then we don't have a standard. Yeah. So when you have a standard, no guesswork is needed. And then improve models maintainability. What does that mean? When you have a design, when you have a system, we build it, we give it to a customer, and then we can't wash our hands. We can't say our job is done now, it's your problem. Because the customer is going to come back to you again in the future. So there is some sort of maintainability also, right? So you can't do the maintenance if the standards are not there, documentation is not there, and building process is not clear, then we have some serious problems. Yeah? And then connected to that is the next point, reduces long-term cost. That's another serious issue as well, right? So if you can maintain, then you can have it for the longer time, right? If you don't have any documentation standard, then your projects are short term. You do it, you forget it. You do it, you forget it. That's not very good for the organization, right? And the last point is very, very important. important also. It says promote reusability. Why is it important? Reusability reduces the time required to do a similar project, similar thing for a new project, because you already done it and it is standardized and it is documented. You just copy paste the code or copy paste the module, right? You are saving a ton of time. And number two, it also reduces cost, isn't it? So if you are reusing code, you don't need to rewrite again. And they are written, tested, and then production level ready. So all you need to do is take it and reuse it, right? So overall, having a standard will actually give us a lot of benefit financially and also time-wise. So we need to look at standards. So when talking a standard, the first thing that comes to our mind is ISO, International Standards Organization. So this is an international body. They have only one job. The job is to give, or rather to create standards so that everyone in the world can use it. So there are all kinds of standards available out there, right? Starting from our USB port to our centimeter, millimeter settings to, all kinds of stuff. We have standards, right? So how do we use them for software development? Well, they don't have a specific one for software development, but they've also tried various things in order to get to that. Now, ISO, I think in lesson 5, we spoke a little bit about it. ISO have numbered standards like ISO 1000, 2000, 3000, and then 1600, stuff like that. So for our own thing, we have ISO 9000 series available. Now, by the way, this is started in 1946, right, in Geneva, Switzerland. So the 9000 standards are generally applicable to all tangible products manufactured, from fans to lights to software. So we have a very generic standard that can be applicable to manufacturing anything, right, including software. Okay. And every 5 to 8 years, they review the standard. Remember, standard must be flexible. So they review the standard and see, okay, do we need to do any changes, right? So the one we are looking at now is reviewed in 2000. So now it's called ISO 9000 colon 2000. Same standard, ISO 9000, but revised in year 2000. Now that also is broken down into few other areas. So there is 9000, 9001, 2, 3, 4. Okay. So 9000 is called the fundamentals and vocabulary. What does that mean? Now when it comes to standard, what I say should be compatible with what you say. When I say quality, I mean something, right? So when you say quality, you might be meaning something else. So there can't be different meaning for the word quality. So the ISO 9000 basically defines all the words you're going to use in your quality assurance system. ISO 9001 is about how to capture requirements, like how to ask questions from customers, how to record it, how to refine it, things like that. 9002 is for production, QA in production, right? Say software development, for example. And 9003 is QA in testing. So these are basically documents, right? Document formats. And 9004 is for performance improvements. Like how do you improve the performance? That's ISO 9004, right? So this is how it is designed. If you look at some of the details, when it comes to models, right? So how are we going to sort of understand these models? Right? Because we are trying to bring in some quality here. So There are hierarchical models that we can talk about. There are theoretical models, data-driven models, and then combined models together. So if you look at the theoretical model, it's based on hypotheses relating among variables. So there are assumptions. Hypotheses mean assumptions, right? So theoretically is based on assumptions. Data-driven, that is based on statistical analysis, statistical data. So if you bring that into testing, software testing, theoretical may be regarding, say, user interface, colors, positioning, sizes, font, because these are very personal type thing, isn't it? You can't have a numeric model as such. There is no data-driven model as such. You may be, but very remote. Whereas when you do TDD kind of thing, where test-driven development, unit-based testing, whatnot. Now there you're talking about data-driven models, right? So combined models take both of them. Good example again is UI, because in UI we can combine numerical based testing, also non-numerical, qualitative based testing as well. Like, what are the preferred colors by people? What kind of people? Why do they like these colors? And why do they like the button on the top right hand corner? And why other people like the button on the top left hand corner? Things like that. So we can combine. There is something called A/B testing, where you divide your crowd into groups and then give one group one design, another group another design. And together you see what they say. And then you need to conduct a survey to find out why they like a certain one and not the other. Right? So it's a combined way of doing things. Oh, by the way, okay, I don't think you heard me talking here. So theoretical model is based on non-numeric most of the time, very qualitative kind of thing. Whereas data-driven model based on numbers, right? Quantitative methods. We can also have combined methods as well. A good example for combined is user interface, where people might have certain colors they like, right? Some people like certain fonts a certain way. Some people like rounded corners. Some people like sharp corners. Things like that. So there is something called A/B testing, where you get your entire population, you divide into two. So you give one half one design and another half another design, and then you bring in the survey details. So you ask them questions after showing them. You ask some questions, and so you bring that in and you analyze it. So that can be a good example for combined models. So if you bring in another factor for this, right? There are two factors here: quality factor and quality criterion. Now, actually, we are going back to our lesson 5, where we looked at certain models. I'll explain it in a minute. So if you remember McCall quality factors, that's what we're talking about here as well. Yeah. So quality factors represent a behavioral characteristics of a system, whereas the quality criterion talks about the quality factor of the system, right? So quality factor, if you look at high-level quality factors like reliability, correctness, efficiency, testability, portability, and also reusability. If you remember, these words are coming from McCall's quality factors, right? Whereas quality criterion, that is like, how do you define these things? The criteria of definition. Yeah. Because now when it comes to software building, we use a module architecture. We don't build the whole thing as a something called a monolith. We don't. We break it down into modules so that we can have a better maintainability and higher quality as well. And also traceability. That means if something goes wrong, you should be able to trace it back to perhaps the feature list or the programmer who did it, plus even the BA person who understood or rather converted the customer requirement to the developer requirement. We can go back. That's called traceability. Okay. So we can also bring in things like customer training or QA team training on the software, right? So these are qualitative most of the time. Now, going back to McCall's quality factors, if you remember this, we had three sizes, three areas, right? Product operation, product revision, and product transition. Okay. So for each one, for example, product operation, we have correctness, usability, reliability, efficiency, integrity. That is, product is being used by the company and the customers. So we can look at the correctness of the software. Is it correct? Is it what they wanted earlier? What about the usability? Is it easy to build? Is it easy to use? Right? Is the text readable? Are the button clickable? Things like that. Reliability is about, does it crash? Right? Efficiency is about, does it require a lot of resources or does it work with the minimum standards? Things like that. And integrity is about, okay, does it change the data properly or is the data transition incorrect? Things like that. On the other side, revision is about maintainability, testability, and flexibility. Now, after you deliver the product, like I said, customer will always come back. So do you have systems to maintain the product? Do you have a system to test it after making any changes? Is it flexible? Right? And then the transition is portability of the product, meaning can you port the product from one system to another system? What are the areas where you can reuse? And also, what about you working with other tools? Like, does your software work with the accounting package? Can I integrate it with the accounting package, or can I integrate with the payment system? Can I integrate with our existing inventory system? Right. So that is interoperability. In fact, if you break it down, if you sort of organize the matters, here is a way to look at it by interconnecting the quality criteria to quality factors. Now you notice one quality factor is connected to multiple quality criteria. Now, when you say correctness as an example, we are looking at traceability, completeness, and also consistency. Those are the three things we are looking when it comes to correctness. Whereas for reliability, we have four arrows coming, isn't it? We have consistency, accuracy, error tolerance, as well as simplicity. Right? If the product is very complex, then we also have a problem in reliability. So likewise, so a lot of things are interconnected here. So this is where we are looking at quality criteria with quality factors. Now here's the other side. If you look at the right-hand side, now we have quality characteristics connected to quality sub-characteristics. Now, for example, what do you mean by functionality? Okay, so that can be broken down. Functionality means suitability, accuracy, interoperability, and then security. Or what do you mean by reliability? Okay, reliability means maturity, fault tolerance, and then recoverability. So likewise, we can break down this. McCall's definition is very good, very helpful, because remember we spoke about ISO 9000 jargon. Here's a jargon. Jargon means words and the definition of these words. What do they mean? Now, if you go to the specific ISO model, 9126 model, so here are some very interesting topics there. Functionality, reliability, usability. Now, they are really matching with our McCall criteria, isn't it? Maintainability and portability. So what does functionality mean? The ability of a system to perform the required function that satisfy users' needs. What does it mean? I bought a piece of software and it does what I want it to do. So I bought Microsoft Word. I want to type letters. Can I do that? Yes, I can do. So then that means my functionality is there. Can I do spell checking? Yes, that is available. Can I change the paper size? Yes, I can do that. Can I take a printout? Yes, I can do that. So functionality is available there. Reliability. Set of attributes that gives the ability of a software to do failure-free operation under stated condition for a stated period of time. Now, can I write a document for 10 hours? Will it crash after 4 hours? No, there is no reason for it to crash, right? So, things like that. That's reliability. Or can I type the document today and save it and then come back tomorrow and open it again? Yes, I can. So the third one is usability. What does that mean? The ease with the software can be used by its end user. How easy, how difficult it is to use. That's what it means by it. Right? Is it easy to use or difficult to use? Efficiency. Set of attributes showing the relationship between the software's performance and the amount of resources used under stated conditions. So does it require a lot of RAM, a lot of hard disk, a lot of CPU power, or does it work with minimum settings? And then maintainability. What does that mean? The ease with which a software can be changed, like corrections, improvements of adaptations of software to environmental changes. Maintainability meaning after you launch the software, if there are any requirement to change, how easy it is to do that, right? That is maintainability. That requires a lot of stuff, right? But like documentation, proper standards, all that. So that's maintainable. Portability is the last one. The ability of a software system to run on different platforms, both hardware and software. So let's say there is a software that runs on Windows 8. Will it run on Windows 11? Right? Or will it run on, let's say, Ubuntu or Mac? Right? So that's portability. So, which brings us to the summary of ISO 9000, the QA principles. So there are few very clear principles when it comes to ISO 9000. Precise goals, objectives related to specific requirements. So they say, if you have a certain requirement, you better very clearly write down what your goal and what your objective is. So ISO 9000 is basically English game. It's all about writing. Yeah. Clarity. And then also clearly identify responsibilities. Now, there may be many people in the team. So who's responsible for what? That's another very important aspect of ISO as well, which is, a good one to have. Then preventive and corrective actions. So how can you do something so that things don't go wrong? Okay. Before things go wrong, what can you do? And then the other one is corrective action. If something goes wrong, then what do you do? Then how do you correct it? Again, you need to have a documentation so that people know how to do something without making a mistake, and then how to do something after a mistake happens. Yeah, both are equally important. Then we have process control flow of requirements. Now, what does that mean? Control flow of requirements. So there is a process from step 1 to the last step, and it is properly documented and flows properly so that at any stage you can stop and investigate and see, okay, what is going on right now, right? And then constant evaluation and feedback. Why is that important? That is important because whatever the standard you are using must be flexible. So you should be able to evaluate and give feedback. And the last one is also important, that is plan, do, check, act cycle. We call it PDCA cycle, where we first, before you do something, you plan and then you do it. After you do, you check it and see, okay, is it what we expected of the plan, right? Yes or no, then you need to act on it. So if it is no, you need to do some changes. If it is yes, fine, you can go to the next one, right? So these are the key principles of ISO 9000. Now, the next one is very important for software companies because ISO is a load of documentation, whereas CMM is looking at what you already have, right? If you don't have, fine, you need to develop something. But CMMi is all about to see what do you have. Well, CMM is the one that was started. I came later. We'll see what I brought in because I was fixing a problem. So CMM stands for Capability Maturity Model. Okay. It was started by Carnegie Mellon University in the US in 1986, very, very long time ago, in order to improve the ISO standard, because ISO is all about documentation and it is not specific on software as well. It's for anything, any manufacturing. It's the same thing they're using for software. So there was nothing very specific for software. And there was a huge requirement for software engineering to have a proper standardization. So Carnegie Mellon Institute came up with the standard called CMM. So what do they do? What does CMM do? So in order to improve a defined process, organization need to evaluate its capabilities and limitation. Now, very, very simple. Very, very simple. Very, very powerful. What does it say? Evaluate what you can do and what you cannot do before you put a standard. That is what CMM says. First, look at what can you do and what you cannot do. And there is no point putting standard if you can't do it, if you don't have people or if you don't have, resources to do that. So CMM look at capabilities, right? So it allows an organization to evaluate the company, right? And if you don't have anything, they will say that you are in level 1. If you have certain other things, they will say, okay, you are, as per the CMM, you are in level 2. So likewise, there are level 5s, 5 levels. CMM will tell you where are you right now. Okay. And also what to do if you want to go up in that level. Now, remember, we spoke about this word called maturity. So what is the opposite of maturity? Immature. Immature versus mature organization. What's the difference here? If the organization is immature, they may not have a defined process. There is no process. Marketing person brings in the deal. Somebody somewhere, whoever free person will start working on the project. And that person is familiarized with Python, he will write the project in Python. If it goes to somebody else and if he's good with Java, he will use Java. So we don't have a standard in an immature organization, right? And if there is a standard, some people may follow it also. All right. So the point here is prevention is better than cure. So you're not preventing. If you see something can be done, you might do. Otherwise, you just go ahead with it, right? Because work is in ad hoc manner. Look at the next point. Serious problem. Cost, time, quality estimates are highly inaccurate. So when a customer asks you, okay, how much do you want for this software? You have no idea how much to quote because there is no quality metrics, nothing. So you might say, okay, give me 200,000 rupees. But then you realize your cost of doing it might be 600,000 because you don't have you might deliver something very quickly, but it breaks down because you don't have a standard and it come back to you. So you have to keep on fixing. During the fixing, you can't give any new work to your programmers. They are busy fixing the old system, right? So that's how a immature company look like. Mature company, how do they look like? They perform its activities in a well-planned manner. They measure both processes and product characteristics. So they have a well-planned way of doing things, right? They measure everything. Process also measured, product is also measured. What does that mean? Lots of thought goes into how you do it rather than just, sitting down and doing things. The aim is to keep track of the progress and quality of products. So we need to track the progress and the quality of the product. And then estimates of cost, time, manpower, quality are much more accurate because we have a process now. How do you maintain that? You give good training to your staff. Proper employee trainings are done. Constant effort is made to improve quality. So from top to bottom, from CEO down, everyone is interested in improving the quality. And then defined processes are regularly updated in order to introduce newer techniques, tools, and experiences. So there are lots of different things, and you keep on updating it to be up to date. Okay, so coming back as an organization, they move from one level to the next. This is CMM. So you start at the bottom, level 1, and then you keep on moving 2, 3, 4, 5, like that. Its process maturity improves to produce better quality software at a lower cost. This is called maturity. Like it is just like, how you become mature, experienced programmers. When you start learning programming, you just, start coding from here and there, no planning, nothing, right? And your objective is to get it done as fast as possible. But then later you will realize that process is not very good because you may do it faster, but you may also introduce a lot of bugs to the software. So you actually end up spending more time later because you have lots of bugs. So as a mature person, then you will go through certain standards. Okay, I need to do this way, this way, this way. I'll design the screen first, get the approval from the customer, and then do my code rather than doing the code and then building the UI also from the code. So that's maturity. Okay. And coming back to CMM, just like the ISO principles, the CMM has certain core principles. Number one, well-defined steps for performing each task. Every task is properly defined, how to do it, right? Right. There was a call. Sorry about that. Now we are talking about the core principles of CMM. So well-defined steps for performing each task, right? Every task is properly defined. And then proper training for each person to perform his or her job. So apart from having a standard, you must also train the people as to how to do the task, which is also equally important, isn't it? And then third is also very important, existence of management support. The top management must understand the importance of staff training as well as defining steps of each task. So in fact, CMM, the first meeting starts from the CEO level or the C level, we call it, chief level, chief executive officer, chief financial officer, likewise. So first training is given to them, not to the developers. So they need to understand, they need to buy in the idea of CMM first. Okay. And the last point is measure, measure, measure. Measurement of all the steps performed. So lots of measuring going on. So only then it will say, right, you are in level 1 or you are in level 2. Otherwise, we have no idea which level we are in. Right? So this colored chart shows the steps. So you start from the first level, initial. Process is unpredictable, poorly controlled, and reactive. What do you mean by that? You don't have any process at all. That's what it says. Reactive meaning you wait till something happens and then you react to it. Not proactive. Proactive is you do something before it happens. So most of the initial companies and teams are at the level 1, initial level. And when they have some standard, they come to level 2, which is repeatable. So you can see some processes are characterized for specific projects and organization is often reactive. Only some things are there, but it is still reactive. So you wait for something to happen, then you act on it, right? And from there, when you come to level 3, the defined level, projects tailor their processes from the organization's development methodology. Now that's a big difference here, right? So in level 2, every project has their own way of doing things. Whereas in level 3, the organization have a way of doing things and every project must follow the organization's level of doing it. Right? Level 4 is also interesting, which is a managed level. Processes are measured and controlled. Now, in the level 3, we are not measuring, whereas with level 4, we are also measuring now. And the last one is optimizing. Focus on process improvement. So after you define and manage, you now look at, okay, how can we do this better? Right? That is optimizing. So these are the 5 levels, which are heavily used by many software development companies. So even in Sri Lanka, if you walk into a large software company, you will see they are using CMM, right? Because that's specifically designed for software development companies. Now here's more details about it. Initial level, what do you do there? The software process is characterized as ad hoc, meaning no plan, nothing. Most activities are responses to crisis. You have constant crisis, everyday crisis, a lot of firefighting, right? So it depends totally on the current staff. As the current staff changes, so does the process, which is very bad, you see. People come, people go, and the company is using whatever the people bring into the table as the process. So the organization does not have a process. Now, from there, we move on to repeatable. Basic project management processes are established to track cost, schedule, and functionality. This is the basic level for any organization to have some order. The necessary discipline is in place to repeat earlier successes on project with similar application. So there is some sort of reuse available as well, but not comprehensive. And the third one is define, where you document things. There are standardized things. There are, way of doing things in the organization. So it's an organization-wide software process. Projects use documented and approved versions of the organization process for developing and supporting software. And manage is where you bring in the measurement side. Detailed measures of the software process and product quality are collected. Both the software process and products are quantitatively understood and controlled using detailed measures. The levels include all the characteristics defined for level 3. And level 5 is continuous improvement, optimization. Right? So whatever measurement coming from level 4 is taken into consideration, and you see, okay, how can we do it faster, better, next time, in the next cycle. Now, in the CMA model, we also have this concept called the key process area, or KPA, not KPI, KPA, key process area, right? What does it mean? Determines a group of related activities which are performed collectively to achieve goals for establishing processes at that maturity level. So we need to look at group of things. What are the group of things that we need to bring in order to get that done in that level? Each maturity level comprises KPAs to identify the area that needs improvement in the organization. So if you want to go to level 2 from level 1, you need to figure out, okay, what are the KPAs we need to focus on, right? For example, to go from 1 to 2, we need to look at project planning and software quality management, SEM. Basic project management is what is required there. Characterization. To go to level 3, you are looking at project definitions as a characterization. And what do you need as KPA? Staff training. Only then people know what to do. To go to level 4, you are looking at process measurement. Now, you need quality management KPA, right? Again, staff training, of course, throughout the system. And the last one is process control. Process measurement, definition, measurement, control. And that is, the KPA is to defect prevention. So what are the processes you have to prevent the defect, like bugs, for example, right? So all this can be documented and trained onto people. Right, now we looked at ISO, we looked at CMM. Now let's look at the similarities of these two. Are they same? Are they different? Right? Now if you take the differences, this is very important, right? The differences. CMM emphasizes continuous process improvement, right? CMM is about continuous improvement, whereas ISO 9001 addresses the minimum criteria for an acceptable quality system. So if you want ISO 9001, you just need to do minimum of those and you will get the certification. Whereas for CMM, it's about continuous improvement. So if an organization is doing something this year, as per CMM, if I come back to the same organization next year, I will see a very big difference there, very big improvement, because they apply continuous improvement for their process, unlike 9001, right? And talking about the similarities, what are similar things of the both? Now, when it comes to ISO, it's all about document. I told you before, right? All about documents. ISO 9001 requires documentation that contain instruction or guidance on what should be done or how it should be done. So everything is documented. What to do, how to do, where to do, who does it, and all that stuff. Whereas in CMM, it's about processes, how to do, but in a process documentation, right? And also maybe there is no let's say ISO process as such, but in CMM it will document the way you do it, right? Now the way you do it might be different to how other company doing it. But that's all right. We have at least one document that says in our organization, this is how we do it. Okay, that's important. And also the CMM emphasizes the need to recover information for later use in the process and for improvement of the process. This is equivalent to the quality record of ISO has something called record, quality record, snapshots of things happening, whereas CMM also has information about recovery. So if something goes wrong, you can always go back and see, okay, what happened, and if this happened, what to do. Because we have a document, we are documenting processes. So these are the differences and similarities of ISO and CMM. Right. Now, all this time, we were talking about CMM, but that logo I showed in the beginning had CMMi. Okay. So CMMi is the latest one. There is a reason why we have a CMMi, because when CMM was released, just like ISO, there were multiple versions and multiple sort of areas. So there was a CMM SW for software. Then there is IPD CMM, Integrated Product Development. Then there is CMM SE for Software Systems Engineering. And then there is CMM SS for Supplier Sourcing. So what happened was many people were interchangeably using this and they didn't have any clear idea about what is what or what is going on or which one to use where and stuff like that. So to stop all that came the CMMI. So CMMI basically integrated all four together into one system. So we call it CMMI. Right? So why do we need the CMMI? If you look at the way we build software nowadays, our software itself is very complex and it has lots of subsystems, meaning we don't have like one big software developed by ourselves. We have lots of integrations like to the banks, to other data suppliers, data storage system, messaging platform. So we are depending on many others as well. Right? So when you are depending on others, you can't break other people's software also. And then you also need to have your own standard, right? So the keyword is coexistence and interoperability. Okay. That is the game of software development today. So we need to figure out the maturity level of an integrated product development process. And then complex software systems usually run on a specialized hardware and a specialized OS. And these needs to be evaluated also. So, depending on the software, whether it is, if you take telecommunication or web services, for example, right? Web server itself is a very specialized hardware, right? And it runs a very specialized, customized web server software. And on top of that, we might have other customized things like databases and other applications and things like that. So unless we have a proper standard where, now imagine something goes wrong with our database server. If you don't have a documentation about how we maintain our database servers, we will have some serious trouble getting another database server up and running. Right? And that's where the documentation is really helpful. So today I went through quality standards. I was building my notes based on the section 9, right, from this book. So I request all of you, because there are so much of stuff that I did not cover here under chapter 9, please go through the chapter 9 to get a comprehensive understanding. There are a lot of calculations were there, a lot of other things were there regarding quality standards. So next time we'll be talking about Six Sigma and see how that is also helping us to write good quality software. Six Sigma is also like CMM, where we do quantitative evaluation of our system, right? So that's what we do there.